All right, here is how you solve a two variable, in this case linear, but it works for non-lines too, which I'll show you soon. How to graph an inequality. So what we just talked about was that not only are there infinite solutions, which there would be for a line, which is all the points on the line, but there's also a whole range of points that would be included too. And so to describe them in words is useful, but to describe it visually is probably even more useful. So in order to graph a two-variable inequality, first we graph the inequality as if it was an equation, which gives us kind of our boundary line. So this is similar to a boundary point, but now we have a boundary line or whatever the function happens to be. So I'm just going to draw a coordinate plane. We've already graphed this particular line a number of times. So the y-intercept is 3. The slope is -2, so I go down 1 over 2, down 1 over 2. And because we are dealing with greater than or equal to, we're going to, it's going to be a range of points, but up to and including the line. So this is the equivalent of a closed circle on a number line. We have a closed line. So I'm going to draw a solid line. That's our way of drawing a closed line. So here's the equals. And then this, in this case, this line kind of divides our coordinate plane into two areas. Everything above or to the right and everything below and to the left. So the question is, which is it? Well, because it's a greater than, we're looking for all the values of y that are bigger than that function. So we're looking at everything above this line. And to confirm that we're right, you can pick any old random point in the area. So let's just say this point here, which looks to be 1, 2, 3, 4, 5, 1, 2, 3, 4. And if you put 5, 4 into the inequality, doesn't make it true. So is 4 greater than or equal to -2 times 5 plus 3. 4 greater than or equal to, -7. Yes. So because that point works, we picked the right area. So what we do is we just sort of shade in everything to the right of the line. And we know it's including the line because we drew on a solid line. So you don't have to like get really close and like color in, stay in the lines like you did, like you learned how to do in elementary school, because the solid line implies that. All right, so really it's just as simple as graphing an equation, and you just need to know which zone of the graph is also included in the solution.